Hello, this is the Data-Centric presentation that I did a few weeks ago on the CEDEC conference here in Tokyo. This conference, it's a conference that's happening every year, and normally it's in live public, but this year was, of course, because all the COVID and all this world situation was not possible, so was made completely online. But so many people ask me if this talk that was online is gonna be available anytime soon or for everybody, and to be honest, I don't know. The conference is not free, even we don't receive any money or anything to do it, but the conference it's not free, so I don't know if there's gonna be released. So I decided to make this re-recording with all the slides in English, and hopefully it's gonna be useful for many of you. And okay, let's start. So basically the title of the talk, it's Data-Centric Rigging, create and maintain large amounts of rig assets. So that was the goal. The presentation, it's based on our pipeline of how we work at ANIMA, and of course I have to big thanks to ANIMA to allowing me to do this presentation. So let's start. Okay, who I am. Okay, so I guess if you watching this channel and YouTube, you know me already, but my name is Mikel Campos. I'm a rigging supervisor at ANIMA, of course, and also I'm mGear framework, one of the developers. We are a team of developers. I'm mainly maybe the head visible of the team and probably like the main maintainer, but there is other people that is helping me with mGear. And also I'm animation filmmaker by night. I try to do my little short films and little projects. Hopefully one day I will finish one of them and also public it here. Okay, so rigging challenges at ANIMA. That's probably it's an important point. So we have several challenges that we face day in and day out at ANIMA. For instance, we have several projects running at the same time. That's almost like the usual. It's very strange that we have only one project running at a time. So the project duration can be from weeks to years, and we have many characters and variations. So when I mean variations, it's like you have this character that maybe has different cloth, or it's been injured, it's in a different after a fight, so he has some broken stuff on his cloth or things like that. So this is what we call variation. So it's the same character, but sometimes it's just maybe the face is the same and completely change the design of the clothing and armor, maybe, or things like that. So this can happen for many variations, and we end up with shows that have hundreds of rigged assets. I mean, hundreds of rigged assets means not hundreds of characters. We have shows that we have like maybe 60, 70 characters with the main characters, mob characters, the like secondary character, and so on. But if you take all the variations that we have, and also we don't do only one rig per each character, we can have up to 4 variations. Like we have like one for layout, one like this complete for animation, and maybe we have one layout with the facial and so on. So we end up with several variants of these or targets, we call targets of these rig assets. So at the end, these rig assets, there are 100 of them, and that's the volume of assets that we need to maintain. So we can also we keep improving all the rigs during the production. So normally we have like the first revision of the rig, or the first publish of the rig, that is the initial goal. And when we start with the layout and we start with animation, and maybe we do also like a lot of cloth animation by hand and things like that. So we have a lot of like back and forward between animation team or simulation team and rigging team, and we keep improving these characters during all the production. So we never stop improving. If we have something that can be better in the show, and of course we have the resources and time, we keep improving until last day of production. We may change the rigs to maybe polish some deformation and maybe to help some look depth stuff, things like that. Okay, so what about the team? Well, basically we are at the time recording this video, we are like 5 persons, and we have some puntual outsourcing. But there is very small team for the volume of assets that we have and the amount of production. So this is we need to manage all this volume with the resources that we have. And also we need to support multiple platforms. And when I mean multiple platforms, it's like if we're gonna render maybe in real time, or we're gonna render a flight render like Arnold or things like that, we're gonna use Unreal, Unity, or it's gonna be like a real-time, totally real-time thing, so it's not gonna be pre-rendered or anything. So that's the daily challenges that we have. So when it comes to create these rig assets, well, obviously there is many ways to do this, but the most classic one is what I call the classic asset-centric rigging. So basically, it doesn't mean that you do it manually, but you have your asset that you build, or you run like auto rig, and you have your scripts that do some stuff, and you do some automatization. But basically, you open the asset and the Maya file, you do some changes, automatic or not, and you close it, you save another version, and so on. So every time you do changes, you keep adding and changing to this asset. And that, of course, it's very easy to use. It's very common. I mean, everybody, I think, knows this approach, and it's the most straightforward in terms of like planification. So you just do the rig. So that's I mean, it's a big advantage. But basically, you can resume this as an open edit save, open edit save. So that all the workflow, it's that thing. So of course, these also have some drawbacks. So let me don't skip any slides. So okay, so what is data-centric? So data-centric basically means serialization. So so you don't, well, basically serialization, I have here the this copy paste from the wiki, but it's the process of translation data structure or object state into a format that can be restored. So basically what we do is we build this rig, or initial stage of the rig. We extract all the data in very small parts, and we rebuild again. So, and we can change the word build by compile. So you can compare this to like a software development. So basically, you take all this data that you build on the asset and extract it in a very small parts. So as smaller as the part, the big advantage is that you can share this part with other assets. So, and this is when it comes one of the most powerful or advantages of data-centric rigging. It's so you can exchange this data between the assets, between productions, or even between targets. So this is very important now because the convergency, or this real time taking over the offline in many situations. So it's very important that your data can be shared between pipelines. And also, like here in Japan, there is many studios, and I don't know overseas, but here I think it's very common that you have studio that have this big IP, and this big IP has the game, it has the TV series, maybe the movie, or maybe other like game platforms, like they have the cell phone game, they have the PlayStation game, and things like that. So if you can reduce the friction creating these assets for different platforms, and you can reuse this data between these different targets, of course it's a big saving here. Not only because you reuse the data, so you don't need to redo it, but also you can maintain this data much more easily. So we will go over this, but basically this is the big advantages. And here, well, I have a little illustration here on the slide, so you can see I have this serialization data, and part of this data can be reused for other assets. So I don't know if it's appreciated, but we have different almost it's the same character with different clothes, different hairstyle, and we can reuse part of this data to the other one. So what big advantage you also have, of course, is the reusability that I was saying before. So you can share data, but you can also, it's easy to maintain because you have this data very encapsulated in very small parts. So this part can be changed in any time, and maybe this part is being used for many assets. So if you need to update many assets that need a little change, you can adapt this part and build again all these assets. And of course, it's very easy to do it because you don't work with the complexity of a full rig or a full asset. You just a small part, very simple, very dumb symptom, like, and it's very easy to change that. I have an example that happened to us like maybe a couple of years ago. It's of course in Maya. So we was running the time the project was working was not using any Alembic caching or anything, so we were rendering straight from the rig. That's not the ideal situation, but it was what we had. And then in some point we had some frames on the render farm that flicker, like pop, pop, pop. Some weird stuff that we played the animation, no problem there, so on. So after some research, like maybe 3-4 hours of research, we find out that if we was plugging some, you know, in Maya you have a transform node and you have a rotation scale translation, and each of these plugs are connected, can be a compound connection or can be like XYZ connection. No? So you can plug one, imagine in the node editor, or you can plug 3. So what was happening is that we plug one, like the compound one, but later the output in, for instance, the x-axis or z-axis was being used for set driving key. Something very, very simple, very common. The problem is the way that the data was pulling, for some reason, was creating these like evaluation issues, and in some random render nodes in the farm was flickering, and it was completely random. No, everything was evaluated in parallel. We changed serialized evaluation or the DG, and it was some back and forward where we didn't know what was going on. And then when we found that, okay, so it's the connection of this that is missing. So what we need to do is, in this case was the joint that was plugged to that, we need to change all the joints connections of all our rigs to be, instead of using the input as a compound, using the 3 different plugs. That, if you have the data-centric, I mean the asset-centric, maybe you need to open each asset, rerun the script, it doesn't fail. I mean, there is no like, but you need to do it like that. The way that we did it using data-centric was just creating one little change on, in this case was in mGear, the way that connects the joints. Just one line, one simple line that connects. And we just send it all the rigs to the render farm that was, I don't remember, but was more like 30 characters and double probably the assets. And in 2-3 hours, everything was published. I mean, we build on the farm, that big advantage, so not in a local machine, but we send it all with a pipeline tool that we have to send all the rigs to farm, and in 2-3 hours everything was published and ready without any problem. So this is the big advantages. And talking about the advantages, the other is the standardization. So this is like almost like a byproduct of the approach, but it's also very I mean, very meaningful and very important, is because it allows to standardize in a way that it's easy to outsource the work and share work with other studios or with other freelancers. And because everything is standardized, because the way it works is very simple, you share a lot of data between all these assets. So if you need to re-edit your asset after a few months or maybe a year that you finish your project or something like that, or it's very easy to edit and to know what was done there. And also you don't have to worry about the who did what. Sometimes you do a rig and you have a team that it's very they have a lot of ownership on that. So if for any reason the rigger is not there in your team anymore, or something happened, I don't know, it's a sick day, I don't know, holidays maybe, so you may find some rigs that you don't know how to edit. And it happened to me in the past and in other productions, and it's terrible because you something that can be very easy becomes a problem because you don't know how to solve it, or it's taking more time than the time that you have, and this is very stressful. So this is the big three win-wins here. Disadvantages, of course, like any other system or process, we have disadvantages. In this case, I will say if it's a very small project, like real small, and it's one character, maybe you have 3 days to rig the character, and it's only you, one rigger, it's not worth to do it. Like it's quick advertisement, things like that, or maybe a project for you, like a little test, something like that. I mean, it's because you have a little overhead at the beginning, so that's true. So you need to be conscious when you can use or cannot use this. But, and this is the point, and this is something I recently, like early this year, I did something like this. It was me, only one character doing some tests. I don't do data-centric. But then this test or this character was edited for a few months, like trying to improve some parts and trying to get the best of that. And it was a big mistake, because even it was only me, even it was only one character, I swear I regret to don't go straight on the data-centric and have everything clean and editable and this flexibility that data-centric allows you. So yeah, again, this is some situations maybe there's more like people prefer to work one way to the other. I think for me it's no-brainer. I go always with that, but I understand that some people for different situations maybe it's not the ideal for the project or for them. So just bear that in mind when you start doing. But for my experience, it's totally worth it. Okay, so to explain this data-centric rigging, I'm gonna use mGear. And I put this slide here in the presentation because the presentation, it was more about the data-centric concept, the workflow, and not the mGear rigging framework. But of course, I'm gonna use mGear because it's the one I'm using it. If you're using another software like Max, Blender, Houdini, or even like now Unreal or Unity that have also like this rigging platforms that are in development right now, if you have the ability to have an API and a serialization, and you can use this data-centric workflow in almost any DCC. I mean, if you have, I don't know which one, but if you're using a DCC that doesn't have like an API and these abilities, probably it's going to be very limited. Okay, so yeah, this is going to be uploaded on their mGear channel, so I guess it's no need to explain too much here. And so let's start with data-centric, and the first thing we need to talk about is the data types that I use in data-centric. So I have the first data type, the serialized data. We will go later over one of these, each of these data types. Then we have the custom steps, and custom steps we can translate this as scripts. And we have the asset. The assets, it's anything that probably it can be like Maya file or Alembic file, FBX, something that you concept, it's an asset. So you have all these custom steps, you have all this data, you have all these like model assets, and you combine together, you build, you compile your rig, and you can create the new version or new change. So serialized data, which kind of serialized data I have? Well, I have guides, skin data, Blendshapes, and I should put an asterisk here because I put it here on this. It can be considered also an asset, or you will see later, depends of how, or a script. So tools configurations, that is very, I think I don't think it's unique to mGear, but I think you will know now that mGear has almost all the tools that create rigs can be stored. I mean, the configuration can be stored, and other serialized data we'll see later. So the guide, and this is something that you should remember always. It's like when you work on mGear, of course, it's that mGear guides are the visual representation of the configuration. That's important. So when I see other rigging systems that maybe the guide, it's the joints that you're going to use for the deformation and so on, and you add the behavioral controls or the motion, I don't know how you call it that, on top of this joint. So it's not exactly the same. This guide represents, it's a visual representation of the configuration, and how you can think about this configuration. Okay, like if you think in Python, it's a big Python dictionary that stores data. That's simple as that. But there is two main components on this this configuration. One is the positions, the important positions that you need to store to represent the articulations or the important positions of a character or other rig asset. And then you have the attributes or properties. I may use sometimes properties, attributes, or parameters. It's again, it's still like exchangeable. I think in Maya it's attributes. Because mGear comes from Softimage Gear, it was properties, and also parameters, like parameters. I think it's more standardized also. So these parameters can be from the number of joints that you have on your arm, like how many sections you want, to if it's gonna be AK, FK, or both, or things like that. So that it's like the description or the configuration of your rig. And like any configuration, it can be stored in another way. So we have the visual, that is the guide, but also can be exported as a JSON format. And I put two images here on the slide that hopefully is representative. One is the first one in the middle. It's the one that it's just the source data. So you can see here you have some on the first red box, some numbers that represents like a transformation. I'm storing the transformation matrix, but this can be like rotation, scale, translation, if you want to think like that. And then you have the parameters values, sorry, that for instance here it's human readable. That's a big advantage here. So the component index, the name, the site, the component type, and so on. So everything is just a big list. And also inside of mGear, I think everybody will know at this point, but you have on this shifter guide manager. Normally you open by default in the components tab, but if you go to the template tab, you can load from file. You can load this same file that I'm opening here, and you can explore it like in this visual image like this, and you can edit here. It's very raw, the edit. It's like almost if you edit in a text file. But yeah, you can do it. Will not recommend if you don't know what you're doing. But yeah, it's there. So next data type. So we have the serialized data, the skin data. So the skin data in mGear we use two basic files. The first one is the skin data itself. That can be also a JSON file or pickle. Pickle it's not ASCII. It's not human readable, but it's a bit smaller the size, and it's a bit faster when you load and save the data. But basically, if you stay with, I normally stay with the binary unless I know I need to edit something. But you can use the ASCII. Now it's not that slow, and you always have the access to edit that. And then we have what we call the skin packs. And okay, what's the skin pack? That's okay. Let me think how I explain that. So you have this data. That's the skin data. That it's it can be G skin or J skin. That's for the binary and ASCII extension. And then we have the and this file can have one object or several objects in the same file combined. Yeah, there. So because we talk about data-centric, that the way that we store the data, that we want to have it as small as we can. So we want to store the data small parts. So if we put one file that contains many objects, let's say this file contains the face and the cloth, and we have another variant of the character that have the same face, eyebrows, everything is the same, but they have different cloth parts that are not the same. So now this file is not gonna be compatible with the other one. It's gonna say, oh well, you can load it anyway, but it's gonna complain like, oh, I don't find this object, blah blah blah, or not same number of points, blah blah blah, things like that. If you store these files in one file per object, you can of course later say, okay, I can reuse these objects, and these ones are completely separated. Okay, cool. So you have this separation, but now how I package everything to make understand, okay, this is a pack for this variation and this is a pack for this other variation. We have the skin pack that is basically a list of all the skin data files. So you can see here the skin pack is just listing, and it's in the same, should be in the same folder. So it's just like a address book with all the parts, and it's nice because you can edit here, you can remove parts, you can copy paste from others, so it's easy to reshuffle this simple list that this one that is going to have way more information. Okay, Blendshapes, nice. I'm sorry, I think I messed here the format of the slide a little bit. Okay, so for Blendshape, I was commenting that I put it here on the serialized data, but it's not exactly serialized data. I put it there, but just bear with me with this one. So we have two ways, especially at ANIMA, how we work, and it depends on the project. So if the project like it's more anime style and it needs to be very specific on the facial expressions, like 2D style, we do this asset plus custom step approach, where the modeling team will provide with all the Blendshapes targets, and we at the rigging team will create this automatization that takes all these targets and applies to the rig. So basically it's asset plus script. If it's another type of project, and in this case, for instance, if the project that we use at Altered Carbon, or before when I was at Marsa with Lupin III, it's gonna be using the Shapes plugin that it's from Brave Rabbit. Ingo, it's doing a fantastic work with this tool, and honestly I cannot live with this tool. So basically here the tool can be also be serialized if you think about extracting the data and then rebuild it again. So it's serialized data. We agree on that, but which kind of serialized data we get? So basically we get some Maya files that can be Maya binary or Maya ASCII, and also the mail file, and maybe some way maps also, that basically the mail file will execute and will rebuild that. So if you think it's not that different, it's the way that we create the data. And of course this is not the only way to do it. There is many other ways, as many as probably riggers, or even more, because some riggers have many ways to do things. So but this is mainly the two approaches that we use, and I think many people use, with especially with shapes. It's a fantastic tool. Okay, Blendshapes, let me, okay, oh, here I scroll again. Sorry, just I'm trying to rush, so it's not too boring, this presentation, but it's a few slides, not too many, but okay, sorry, I also messed here the format on the slides. I was trying to arrange this a little bit before the recording. Sorry for that. This is tools configuration and other data. So for the tools configuration, just a simple screen capture with some of the tools on mGear framework that will have this kind of configuration, so you can export this configuration, like the facial rigger or the RBF manager, also the soft tweaks manager, the picker, so on. This is like tools that you can save your configuration, and next time you build a rig, you can rebuild the tool. So it's not like you save the output of the tool, but you save the state of the tool to build again the output. So that's important. And then we have other data that we export. In this case, for instance, we export wave maps. So wave maps is like skin cluster data, but instead of have like an array of deformers, it's just one deformer. Like, so in Maya, this black and white, no, 0, 1 kind of thing. And yeah, we have a custom here's exporter. It's not yet on mGear, but I'm planning to add it, so you will have access to this. But basically it's like very simple, like non-linear deformers, weights that you can export. Okay, so let's continue with the custom steps, or what I said before, like scripts. So basically, before explaining the custom steps, I want to explain a little bit about mGear, or in this case Shifter, that is the modular rigging inside mGear. The how it works, because the way that it builds the rig is by steps, and that's the reason because we have later the custom steps. So we have the default steps and are here in this image that you can read by yourself, but I'm just gonna read it like you have all the steps. That is the default one, and you can build the objects, properties, operators, connect, joins, and finalize. Finalize does like kind of like housekeeping, like cleaning some stuff and things like that. So basically what it does is when you have several components, like let's say I have a spine and arm. So the way that it builds is not like I build the spine and connect all the joints and add all the constraints and add all the controllers, and then I continue with my arm and I add this. It doesn't work like that. What it does, it's getting hot here, sorry. It's gonna build by parts. So first it's gonna build all the objects of the spine, all the objects of the arm. Then it's gonna create all the properties. And remember, I'd say properties, attributes like IKFK, things like that. When well, I mean in the channel box when you have these attributes, so it's the same. Then it's gonna create the operators. Operators is anything related with the behavior, also like IK solvers, constraints, expressions, other attributes, connections, things like that. Then it's gonna do the connect, and the connect is gonna connect the relations between the different components. So the relation between the arm and the spine, or the arm, shoulder, spine, and things like that. And why it does it like this? Because when you do the connections and the properties on all these operators, in some situations, like you have the foot and the leg, it needs to change some relations there, because if you are in IK, it's gonna behave one way, so the banking of the foot is gonna affect the behavior of the leg. But if you are in FK, it's gonna be the other way around. So the only way you can create these relations is when you have everything in place. So if you finish one part and then you have to add the other one, obviously you need to do a lot of like disassemble part of what you did and reconnect again. I mean, it's possible, but this is kind of like more straightforward because you have everything ready to do. So this is what we call the steps, the basic steps. And then we have the custom steps that are the pre and post. So we have this like pre will run here and post will run after finalize. And basically just scripts that will do something before and after these steps. And here's an important note here. I think, yeah, I don't cover with my face this part, that it's green are shared. That is important. So it means all the data or all the custom steps that you see here that are green means are shared between the same object, same character variations, or maybe for all the characters, or even for all the production. So that's important to remember, because we try to share all this data, to share all these scripts, so we limit the points of addition of all our assets in one simple like exact point. So we avoid like code repetitions, things like that. That's more common in development. Yep, I think that's it. And or ideally goal, it's almost everything green, but yeah, sometimes of course it's not possible, but yeah. Okay, so let's move to the custom steps anatomy. Whoa, fancy words. So basically we have this class custom step shifter step. We have a run method, that's the one that you always have to implement, and you have a way to access all the data inside of these custom steps, but also in the like say the original steps, the what I call the mGear run. This is the mGear run, these ones here, and the pre and post. So here you have a way to access that. Of course you can access by string, by the name, so if you want to access to a node or something like that, but here you have an access to everything like variables, so all the data. You don't need to rely on names, you can rely on the access point that is giving you. Okay, so the custom steps parent class, there are only two methods. The most important is the run one, and you can see here it's just raising an exception if you don't implement it. So that's as simple as that. And we have a dub, that is duplicate. And original idea here is to add more like this kind of helper method that you always use in many of the custom steps. But for the moment we have only that duplicates like an object, and it will make some kind of heuristics to put the right name in, so it doesn't have name clashing. But it's very simple, to be honest. The most important is the round one here. So how we access the variables here? So everything is in a custom step. I'm sorry, in a custom step, in a dictionary, and this dictionary is called custom step dictionary. And inside this custom step, the first let's say key that we have on this dictionary is the mGear run. So basically it packs all the mGear run there, just passing itself, and you have access to anything. So if you had like 6 sections on your arm and you want to know how many sections you did, you can check this attribute or variable or parameter, and it will give you this information, and you can reuse it for, I don't know, anything you want, but it's up to you. So later we have another like way to access, that is the step dictionary and the name of the custom step. So you can see here I have a custom step called init base, and I have this object that is spatial local setups, and I just access this by doing this. So the name of the custom step is set here, mouse slide in this case, and it's accessing one that is been previously executed. So if I go back, this here init base, you can see it's here. And then if we want to access to the components that it's been on the run, then you can access mGear run.components and the name of the component, in this case mouse z0, and you can access to the lib up control. So this is access giving you to the PyNode object of the control itself. You can access like creating the of course the name of which using the string of the object on, but this is, I think it's a more elegant way to do it, especially let's say I don't want my lib up control, it's gonna be, I don't know, mouth up control, I don't know, you want to change the control name, so you have access always here to that. The custom steps doesn't need to be always with this custom step class. You can also run general like Python scripts. So basically it's gonna try to find if you have this class and execute the run method. If you don't have it, you have a regular script that prints something and do something, it's gonna work, so it's no big deal. You cannot run you cannot run mel, it's not supported. Okay, so this is the 2 ways to access the data on your custom steps. And now custom step production example. So here I have this is a production example of the facial rigging setup that we did for Altered Carbon. It's very similar to the one that was done for Lupin at Marsa. Here it's simple than Lupin, of course. But it's not that much different. I mean, in the workflow is the same. So I'm just running here with this GIF, saying all these custom steps, and here just a little plug. Probably after this video, I'm gonna start or restart the facial rigging workshop that was in my to-do list almost for 2 years now. Sorry for that. I already started, so it's coming, it's there, and we'll dig on that more deeply. So this is just a little plug, and I wanted to do this presentation before the start the workshop, because many of the topics that we talk on this presentation, it's gonna be again take over on the workshop. And yeah, I totally recommend, I will also advise on the workshop first videos to watch this one, because you will have a good base to understand better, or if you did, of course, the previous workshop is also better. But yeah, I hope this presentation is a good kickstart for everybody. Okay, assets. So assets is what I was commenting. It's Maya files, ABC, like Alembic files, anything that can be like format standard thing, I consider as an asset. Even a little Maya file can be like a model itself, or can be like a little rig. So you don't, when I say I want to reuse always everything and share the data and extract, serialize, and build again, this is the ideal situation, but in some situations, like if it's a very small thing, or maybe one character has something that you want to do by hand, so you can save this part of the rig as a Maya file, and then you load it and you connect again with the fresh rig. So you ensure this part, like, I don't know, maybe it's a ribbon or maybe just a flower or something that it's, for any reason, it was handmade, and you want to reuse that rig as is, so just save that part and rebuild. So you can do that. I mean, the most important here is, of course, is giving options to any pipeline or any approach to have all the flexibility possible without a restriction. So that's important to keep in mind. Okay, so now that we have all the data and we have the custom steps, where and how we store this. So then is when it comes to folder structure. So this is the folder structure I use, and it's very simple. I have 3 main folders: assets, data, and scripts. And inside the script we have post and pre. That's it. Then I used to have one for skinning to store skinning, and then it's pretty like flexible. We can do anything we want. And then for each variation of the character, depends how you want to organize this structure. You can have like some like, for instance, we call it here basic, facial. That basic will be the layout, basic facial will be layout plus facial, the cloth variant, the complete with facial. I think it's self-explanatory. And all this, of course, we have one that is on the same level that is called share. So let's say this character, or this variant of the character that will be the default one, it's it has all these targets, and you have a top folder that it's called share, and I put it here in red, like very clear. This name underscore share is the one that mGear will recognize, or shifter will recognize, to make the green highlighting and say, okay, oh, this is a share folder, so it means this is share for other. Of course, there is no magic trick or anything there. If you don't put it on the share folder, you're not gonna know if it's share or not. I mean, you need to somehow mark this. But the folder structure is pretty free. I mean, you can do whatever you want. The only thing is you have this special naming convention that will demark like something that is shared on the custom steps. So here I have the shared data. So let's say I have the facial, and I have facial here, and I have facial here. This and this is the same facial. So where I'm gonna store my data for facial for this character, it's gonna be here. But this is the default variant. Let's say I have another variant, like this, let's say the armor variant or any other variant. So maybe I put it on the top folder. So all the variants of the same character have shared data. That it's how organized. And of course, if this is shared by all the characters of the show, you put it on the top of the folder that all the characters are stored, or top show, so on the custom steps root share folder. So you can put these share folders any place you want, and you have some clear like meaning where is it. And also when if you hover your mouse on the share folder, sorry, on the share custom step on the UI, on the custom steps UI, it will tell you who is the owner and which div is. So we will see this on the Data-Centric workshop for the facials. And here is just a little GIF with scrolling down all the data that can be stored in one character. So you can see it's many files that represents different kind of data. And yeah, that is how it's been done. Now, how we build this? Well, different ways to build. The first and most easy one is to build from selection or build from the guide template. So you can export the guide template, that it's just a description that we talked before, and you can build it again from that serialized guide, and this is the build the rig description. Or you can build from selection if you have the guide loaded on your Maya file, on your Maya scene. You can also use script. So in this case, you will import from mGear shifter import IO, and from IO build from file, and then you put the guide path to your server, or the serialized file that you just created with export guide template. That is here. On ANIMA, we have a much more refined tool. It's called the build and distribute rig, and we call it the rig builder. And basically, the tool was developed by Rafael, and basically it's this tool we can serialize or serialize, just send to the farm many assets at the same time, many variants at the same time, but also does more stuff. We can run some quality control test. We do like mainly the visual quality controls that there's just running some range of motion and facial motion on the characters that goes to the farm, renders and speeds like video, like image. Also, we have these validate plugins that it's using the Publish framework from Marcus, and we send all this to the farm, so we can build locally on the machine if we want, or we can send it to the farm. So we send it, it runs all the tests. If something fails, it's gonna fail the render job, and if everything goes well, it's gonna show up on the other side of the pipeline ready for the animators to start animation. So that is the process that we use at ANIMA. So I don't have the data yet ready, but we're gonna share data, like sample data of this talk. So we're gonna share this girl here, that it's the ANIMA girl, but she doesn't have name, so just put in one randoms with some variants and some sample of custom steps, and hopefully with this talk and all the, of course, the folder structure, everything will be there. So if you want to get access to this, just follow ANIMA at ANIMACG on Twitter. I will post it also on my personal Twitter, and of course share it in as many places as we can. But since this talk was under the umbrella of ANIMA when I did it, and these models are I mean, it's an ANIMA team who did it for this presentation. It's like kind of like sponsorized by ANIMA, let's say like that. But yeah, I want to know that mGear, it's completely independent of ANIMA. So if you have problem with mGear, you can go to the forum, talk with me, talk with other developers. But ANIMA, it's just like it's the company I work for, and they are supporting mGear. So it's very, I mean, bear this in mind. So don't send emails to ANIMA if you have any issue or anything. Just please contact to the mGear development team. So last but not least, this I should make it in a separate video, I don't know, but since it wasn't the presentation for CEDEC, I just decided to keep it here. I will do another video later, maybe this month, maybe early next month. I hope I have time. But basically what's coming down the road for mGear. So game pipeline improvements, that's the main goal right now, because I was saying like the real time, it's getting, I mean, it's very, very important. Of course, for games, it's no brainer, but also like for offline rendering and all the productions, it's all converging into some common language or some common workflows. And it's very important for us to support this. So we're gonna do the next release, I hope soon, and it's gonna have these improvements on game pipeline. So right now the custom steps, just talking too much. Custom naming conventions for control and joints. This is already done. This was probably the most complex part to implement. Just finished last week, I think. My original roadmap was to finish in May or June, so just a bit delay. So we are gonna make also, I'm gonna make some what we call epic components for Unreal Engine. So basically we're gonna take the Unreal mannequin naming conventions and joint orientation structures, things like that, and we're gonna make it compatible. So if you're using art or the other mGear, Unreal Engine kind of naming conventions and things like that, and you want to try mGear but without losing your data, like skin data and things like that. So hopefully these components will allow you to recreate your asset, just extracting of your data that you have from your previous rig and rebuild it on mGear so easily. And we want to make the the workflow more easier. So I was watching this Blender integration that Epic team did, amazing work on this kind of bridge that they have to send the FX data semi-automatically and so on. So we will try to create this partly, not the round trip. I saw this demo. I don't remember the developer, but it was really great, and they had this round trip work, so you can send back to Blender and so on. So for the moment we're gonna focus just to export to Unreal, and of course to FBX and all other game engines. Of course we want to support any game engine like Godot, Unity, or any proprietary game engine that you may have been working on that. So hopefully with these custom namings and everything will be much more easier to implement mGear on existing pipelines that already have some kind of naming conventions and structure in place. What's next? So after that, and this is just the ones that we want to do. We can promise anything. This, mGear is an open source free project. We try to do our best, all the team, but sorry, we cannot promise anything because it depends of our like, let's say day work and how busy are we, and if or maybe if our goals change on, like, depending on the time. So this maybe change a little, depend. But one of the things is a stepper flow. This is one of my goals since long time ago. So it's nodal processing graph, and I put some example here. Just this is not representative of anything. It's just it's a capture from another graph Qt that it's a open source node graph available on GitHub. I just put this as an example. So, and this basically will not replace, but will be like a big daddy of the custom steps. So this will run, the custom steps runs inside Shifter. So this will wrap Shifter on top and will process data. And hopefully it's going to be much more easier with a nodal approach. We will have nodes that can run scripts, so you can have all the flexibility, but some of the scripts that we are running is import skin, import this, do this, do this. So hopefully we will have wrapper nodes for everything. So for instance, if you do like iRigger and you export this data, now you have a node that build the rigger. So you just need to point where is your configuration data and it will build it. So, and hopefully it's gonna be so much more easier. We want to even to run outside of Maya, so you can run Maya batch and make some kind of branching and things like that. But yeah, it's a bit early to talk too much on the details, but this is one of our goals that we want to have. So make this data-centric process much more easier, faster, and hopefully more accessible to more people that are not that technical. Shifter 2.0 also, it's very important. So the Shifter is the modular rigging system. So we want to make a full refactoring, cleanup, a lot of things that yeah, we want to add and we want to improve. So I hope it's gonna be really step forward on that. And Python 3, it's gonna be standard. It should be this year. I think it's gonna take a little longer, but it's gonna be sooner or later there. So we want to be ready, and everything should be Python 3 ready. So it's coming like this tool, and then it's gonna be like a big refactor. That is our goals. We all, of course, will have other like little tools coming, popping, bug fixing, improvements. This is of course, but this is our goal. And yeah, I don't know how long it's gonna take. I mean, it's been in my roadmap for a long time. It's not a promise, it's just a wish I can deliver, or we can deliver. Rigging team, sorry, mGear team. But yeah, it's something we will see little by little. So that's all. Thanks again to everybody for your time watching this. It's almost 1 hour running. It's not that bad. Thank you to ANIMA for the support to mGear and to allow me to do this presentation. Thank you to the ANIMA modeling team that worked really hard to create this sample data that will be shared, I hope, soon. And thank you very much to all the mGear development team and all the mGear community for all the support and all the help that is they are giving to mGear project. So thank you so much. Remember to follow ANIMA at ANIMACG in Twitter, so we will share there all the data when it's ready. Thank you so much.